Yeah, good so. Okay, hi, good afternoon, everyone. Thanks for joining this session as well. As you can see, well, as you saw, Kris is going to tell a little bit about running Slinky on Azure Kubernetes service. One of the reasons why we, Microsoft, asked INUITS to help us sort of like set up that scenario is as Microsoft HPC, we're trying to do a lot of with open source environments. We are working quite a bit with Easy as well ourselves, both in demos and with our customers. And there are several scenarios that we have invested in earlier years as well. Things probably Casper will touch a little bit. We try to help a little bit with the NVIDIA GPU environment and some very early work of the ROCm environment as well. And it's awesome to see that is still progressing. Right now, what's going on with Slinky, and you mentioned that earlier, ScatMD is acquired by NVIDIA. One of the projects that they have been working on is having the Slurm scheduler available in a Kubernetes environment. What we are seeing right now with the big AI workload growing further and further is that originally it was pure training that customers were asking. Today, there's a big emphasis on inferencing. We see that the inferencing workload is running much more in a Kubernetes environment, but while that workload is growing, there is an additional ask on saying, hey, we still want to train, and we want to train that at irregular timing. So we don't need it full time, but we need it in certain periods to do some retraining, fine tuning, whatever. So integrating Slurm with AKS is going to be giving an additional value in that AI environment, and that is one of the reasons why we asked INUITS to help us sort of like figure out how Slinky can work on an AKS environment. That being said, AI is not the only workload that can work in this, and we have been using Easy again to prove some of the features with respect to InfiniBand usage and GPU usage. And I think the slides are up.
Yeah.
I've talked just enough. So let me hand it over to Kris. Thank you very much. Enjoy.
Yeah, the slides are up. So, good afternoon. Thanks for the introduction. And that's basically what I'm going to be talking about. My experience with setting up Slinky on Azure AKS, basically figuring out how all this stuff works. I'm new to this group. Well, not really new. A bunch of people have seen me before. A bunch of people actually worked with me before. But ages ago, I used to be a developer. Then I became the guy racking machines and doing operations. I co-founded INUITS. I co-founded DevOps Days. I co-founded Config Management Camp. Most people curse at me when they run into DNS problems. And for my HPC background, I used to be the OpenMosix release manager back till we abandoned the project. And actually, Kenneth took over my job of running the HPC rooms at Tosdem, but there was a gap of about 7 years between the last one I ran and the first one he ran. So,
you just say that.
What was that?
I don't know, somebody on Zoom.
Go on, all right. So, traditionally, HPC environments are run on bare metal. And on machines you have, but there's also this thing called the cloud. And for a lot of people, the cloud means running Kube. So this project basically for us was to figure out if we could run Slurm on Kube, on AKS, and actually benefit from having GPUs and InfiniBand in there. And the focus was really on functional validation, not on performance, not on seeing how fast this could be done. That's a totally different thing. All of the work that I'll be talking about is available on this GitHub repository. Opened it up yesterday, and all the documentation, all the infrastructure as code, all the example jobs are in there. In the presentation, I'm only going to be using small snippets, sometimes stuff cut out because, well, screen state. So what is Slinky? We're still using Slurm here. So Slinky is basically Slurm on Kube. Do I need to explain what Kube is? Hope not. Well, it's an orchestrator. So you're running an orchestrator on top of an orchestrator. And you can figure out which one is the good one. There's a couple of projects they have. It's basically the Slurm operator. There's also the Slurm bridge, which basically bridges an existing Slurm cluster into Kube. But we've mainly focused on the Slurm operator, not on the bridge. What Slinky provides is basically a Kubernetes operator, a bunch of containers, like all of the Slurm components you are familiar with. They now have container versions for that. And it also, with the operator, deploys a bunch of node sets that are the actual Slurm worker instances. There's a bunch of tools that I used to set this up. What just happened?
Oh, maybe just went sleeping.
Yeah, probably went just sleeping. So there's a couple of tools that you might or might not be familiar with. First of all is the AZ Azure CLI tool, which you need to actually log into Azure and to do things like spin up registries. We use OpenTofu for infrastructure as code. OpenTofu is not a 100% compatible fork of Terraform anymore, because since the last releases they actually diverted. But it's the actual open source variant, since HashiCorp screwed us all, and yeah, that's what they did. I mean, let's face it. They just stabbed the open source community that built their big community and figured out they were going to go proprietary. So what we did with Tofu is basically create on AKS a bunch of resources, bunch of node pools, system node pool for the management ecosystem, the AKS cluster that's being spun up, a bunch of HPC node pools, nodes, and GPU node pool, and we used a couple of example VM types to actually do that. We also used ESSI, but I guess tomorrow there's going to be a talk that really explains how this works. We used the Helm provider to actually set up the CVMS CSI operator and installed it. So once we had that installed on every file system, on every pod we spun up, we now have all the ESSI software available for usage. It's pretty trivial to do so on Kube. And then we went on using Helm to install all of the different components. So the first thing you need to do is install the Slurm operator CRDs. Then you actually install the Slurm operator. And then at that point, there's an ecosystem running in Kube that knows if you say, hey, now install me a Slurm instance with a bunch of variables which you can, so the charms and the values you can find in the Git repositories. And if you look at the Git repository, there's going to be different values files based on the different stages in the document. So this actually does a Helm install of the full Slurm ecosystem. And when that is deployed, you actually have all the components you need available. No, that's not my water. So if you then look at Kube and you see what's running there, you see the typical components you would expect in a Slurm ecosystem, but now running on Kubernetes. So there's a controller, there's a typical login service, there's a REST API, and there's a bunch of worker nodes within the different resources. And those are split over different node sets. And from then you can basically log on to the slogin pod, and then you can start using Slurm as if you've been using it all the time. You can have all the components, all the comments you are used to available to you. So this is an example of cluster running with two partitions, one with GPUs and one without. So yeah, basically that was the first part, getting Slinky to work, getting to have access to Slurm set up on AKS on a Kube cluster. And then the next part was trying to figure out how to get InfiniBand working and how to actually get GPUs working. So that was the second part. And to do that, we needed to figure out how to get access to the hardware. So within the Cube ecosystem, there's a bunch of operators available to do networking stuff and to do GPU stuff. So step is to figure out to install the network operator and do node feature discovery in there. But once you install the network operator, you need to actually tell it which hardware it needs to look for. You need to actually have a bunch of node feature rules that do the detection and do it right. And there's where the most complexity of the whole thing happens, because most of the examples you'll find on the internet just have a couple of PCI IDs listed. And the challenge is to figure out which hardware you have and have the matching PCI ID listed in your configuration file. Once you have that, and you have that network operator YAML file configured with the PCI IDs of the hardware that you have available in that cluster, it basically allows you to have a kubectl describe a node, and it will then detect that the hardware you're actually looking for is present. And as of that moment, you can start playing with it. Then you actually install the operator, and the operator is gonna help you with all of the different components. So that's gonna install the Mellanox Open Fabric driver. It's gonna have the multi network CNI, so you have support for multiple network interfaces. It's gonna give you an IPAM, and it's gonna give you IP over IB support within Cube. Thing is, not all of these things are gonna work within the vanilla Slurm containers. So you're gonna have to rebuild those containers, and you have to add support for them. So that's why we also set up a custom local registry, well, in Azure, so not a local one, but one specific for the project. And from there, we were basically building the containers. So Slurmly, we build again, and we, just like you would build a different Docker container, you build it, you push it to your registry. And we did that for a bunch of the test workload nodes, for the Slurm worker nodes, and also for a bunch of the InfiniBand test things. So once you have that in place, you have the images built, you have the network feature rules there, you have the network operators there. You wanted to deploy an example of your network. You need to basically create a pod specification where you actually say, I want to have these RDMA specs, I want to have this CPU, I want to have the image listed here. And once you have that in place, you can start with running those nodes and figuring out how those can be used. Because once you start the containers, it's still need to have some more labeling done so you can get the additional network interfaces. So if you here see the test pod spinning up for the first time with the different network layers, this is a different network than the default. And then you can start playing and testing around. First test obviously is to see if you can do a ping over the network, and then you want to do some performance testing, look at the latency. And you can clearly see the differences in throughput between an actual, wait, which one is the upper one? Between different nodes where the latency and the higher throughput, the throughput is higher and the latency is lower, so you can clearly see that it's much faster over the Mellanox interface than over the InfiniBand, over the network interface. That was in an isolated test setup, just getting InfiniBand to work. The next step was to get that to work on the Slinky pods, and therefore we needed to build a different image. As I said, we need to have additional labels, so the InfiniBand networking got picked up. We need to have the resource limit defined. Well, we also wanted to have ESSI in there, so we combined it with adding the different multiple mounts for the containers and the different shares in there. So that's yet another values.yaml we had to create. And in the Git repository, you'll see that that actually includes all of those different changes. So that was, again, these different changes that you need to make. For the volume mounts, these are the typical volume mounts and the volume definitions in Cube, persistent volume claims. And then also for the networking, the annotations you wanted to have in the IP over B network, and obviously also the local Slinky pods that we built. So that was for us the first time to actually start testing if we could run some application that was gonna use all of these components. And obviously we used the ESI repository to take one that some of you guys might have been built before. We had to use the test case B for the GrowMax test setup. And then we actually, first time we saw really running all 7 nodes, 44 cores per node from within a Slurm job on Slinky and AKS, what we wanted to do. And yeah, you see the network stuff here too. So that was our first success. We had it working over InfiniBand. We had it working on AKS in Cube. So the next thing we need to do was to add GPU support to that. And there we could benefit from the NVIDIA operator that does a lot of work for us there. So again, using Helm to install the NVIDIA operator. This again deploys a number of pods that are also going to do detection of the hardware that's there, feature discovery. They're going to have support on kernel level, going to have support on device plugins, and they're basically going to make sure that Cube now also knows and also has access on container level to the hardware you need. Again, similarly to telling a pod that it needs to have InfiniBand access, you also want to have definition in there that you have a GPU. So you've seen 2 node sets in the presentations. There's Slinky and Slunky. Slinky was the original ones. That's the one we did with InfiniBand. And I just had to use a random name. So Slunky are all the ones that have a GPU support. And rather than having a node set with both of them, we now have 2 different node sets defined. So there's a lot of duplication in the YAML there that has that. And then the next step was actually running this and testing that we had GPUs. And this is basically an examples batch job that we run where we could actually test that it was running on a GPU. So that's a basic random test GPU job, which is also in the repository. There's a couple of things you need to do to actually also tell Slurm that it knows it's there, because otherwise the orchestration is not going to be good. So that's another update in the default configuration you need to do. You need to make sure that it's doing auto detection, and that way it is going to do much better scheduling. And then the last step was basically combining it all, making sure that we had a job that we could run again, GrowMax in, and that was basically on 2 nodes with GPUs. We ran the whole setup again and proved that we had support for running GPU stuff on AKS in Slurm. And that was pretty much what we did. The code base is out there, both the tofu code to spin up an AKS cluster with all the required node. There's all-in-one script that lets you do everything all in one setup. There's also, but that's not yet in the slides yet and not in documentation, an Argo CD repository where you can basically just deploy through Argo also all the components. Took us a bit of time to debug a couple of things left and right, but it's quite possible to actually do this yourself, given the documentation that's out there now. So yeah, that's what we did over the past couple of months.
Just heavy.
Questions? Yes.
Slurm uses a database. Where is that?
Come again?
Slurm uses a database.
Slurm can use a database. I would recommend to use an external database, not run it in Cube. It's not in the slides. I did the test setup for a disposable database. We ran MariaDB in Cube. I would not recommend that for production, because even during my test, the number of times I actually lost data, I stopped counting.
Okay, that's why I asked you.
Do not store data on persistent volumes claims. Still not. Databases in production on Kube. Just don't. Whatever other people tell you. I mean, because of this proof of concept, I said, yeah, whatever, it's proof of concept. I'll do it. I think I stopped trying after the third time. And then I just disabled accounting in Slurm because I know it worked, but just not worth the effort. Just use a database external from your Kube cluster and run it there.
Just to confirm, so that's a general recommendation for anything with databases.
Sorry?
That's a general thing for anything with databases.
Yeah, that's a general thing for anything with storage and I/O requirements. Yeah. Containers are supposed to be for stateless, short-lived, and disposable applications. If your application doesn't fit those requirements, refactor your application or find another way to deploy it. It's the only thing I can say about it. Or shoot yourself in the foot if you prefer, but yeah.
So making this whole puzzle took you a while. How much of this is like non-standard? I can imagine not too many people have done this with InfiniBand. GPUs is, I guess, a different story, but what was the most difficult part or the most work to figure things out?
The most difficult part, besides the general Kube annoyances, I think for most people, the most difficult part will be figuring out the hardware integration. Like figuring out the PCI IDs is going to be, for most people, the most complex thing. Mm-hmm. But apart from that, it's Kube operators, it's default Kube stuff. Once you are used to working with Kube, that is pretty trivial. Mm-hmm. But the hardware integration is the non-trivial part.
Yeah, they're supposed to be independent from the hardware, and that's exactly what you don't want. So.
Yeah, and then you're tying the hardware back in there.
Yeah. Okay. Anyone else? No. Okay, then I think we can wrap it up here. Thanks a lot, Kris. And we'll get ready for another series of site talks. So, Alexander, you're first up.